All right, we're good to go. Starting a little later, but I'm not too worried because we're going to be able to skip over some of the material in here because Vigisha already told you all about it. We're going to talk about, still staying within the Panorama ecosystem, we're going to talk about QC with Panorama. And I say QC, but right off the bat, we're going to talk about how it's not QC, it's actually system suitability. So I have two main points that I hope you take home from this section. The first is gaining some exposure to Panorama QC. So you're already ahead of the game because you already have exposure to Panorama Public. So Panorama QC will just be an extension of what you just learned. And then second is, if you don't already have a little bit of an intuition for LC-MS troubleshooting, I hope you gain some perspective on what good system suitability should look like. So like I mentioned right off the bat, system suitability is not the same as quality control. So system suitability and quality control, the difference is that quality control is for your sample prep method. So quality control is, did I prepare my samples correctly? Did I digest my samples to completion? Did I enrich my samples efficiently? Things more along those lines. So the QC is specific to your particular method. On the other hand, system suitability is designed for your system, your LC-MS system. So a system suitability sample can be a lot of different things. What you might use for system suitability should reflect whatever type of mass spectrometry you're doing in your lab. It should be a sample that is stable and doesn't change over time. Whatever type of sample you happen to be running on your system should reflect that type of sample. So if you're doing proteomics, if you're doing peptides, it should be a peptide sample. If you're doing top-down and you happen to be in this bottom-up targeted course, you might have taken a wrong turn, but proteins should be your sample. If you're doing small molecule, it should be a small molecule system suitability sample. The more inexpensive, the better. So a lot of labs do kind of go out of their way and buy, for example, those PRTC peptides, those IRT peptides that we had talked about yesterday that we used for the retention time calculator. So some people use those, some labs use those IRT peptides as their system suitability. That's a very stable sample that you can purchase and it will be the same every time. Other labs, maybe more academic, that don't have the money to burn on IRT peptides might use a cell lysate, like a yeast or a HeLa cell lysate that they prepare in bulk and then put in their freezer in aliquots and then just take one of those aliquots each time you go to test the system suitability of your instrument. So now that we have maybe a little bit of an appreciation for system suitability and what we're going to be doing on our mass spectrometer, I'm going to review extremely quickly kind of Panorama. I'm going to talk to you about SProCop. I'll talk to you about a small tool called AutoQC. And then I'll show you some data that ties all this together. But first, just a very quick review of Panorama. You just heard a lot about it from Panorama. Now I'm just going to reframe it from the point of view of an experimentalist. So I am a data generator, and I am creating all of my data. This is how I view Panorama. The problem I saw was that people, researchers like me, were pouring all of this time and effort and money and sanity into developing a mass spectrometer assay, and then it would die. Either it would be published, but then just languish and nobody would ever bother looking, or I would go to conferences and say, like, I know that peptide by heart. I made an assay for that. Why didn't you just use my assay? So the idea behind Panorama was trying to disseminate the product of our time and effort in a way that wasn't just publishing it in a paper that then languishes. So you kind of saw this overview. I'm going to skip through this pretty quickly for your reference. All the same things Vigisha was saying just before this. So SProCop is switching gears a little bit. This is Statistical Process Control for mass spectrometry. So this is, he was a postdoc in the McCoss lab, and now he's at NC State Michael Behrman a few years ago noticed another problem in the field, and that was that there was really no way for people to compare the quality of their mass spectrometry data. Just there were, word of mouth, like, oh, this lab makes really high quality mass spectrometry data sets, or like, oh, this lab has kind of sketchy mass spectrometry data sets, but there was no metric to measure the quality of a mass spectrometry data set. So the idea he had was this vendor-neutral tool that would quickly assess how well an LC-MS system was performing. So what exactly does this mean? What he was thinking was things like, is the LC performing correctly? Is the chromatography look correct? Does the mass spectrometer look clean or dirty? What's the signal in the mass spectrometer? What about the mass accuracy? Is it calibrated? Take all of these metrics, feed them into Skyline, have Skyline somehow make all of these quality control charts that you could quickly look at to assess how well an instrument, an LC-MS system, was performing. So he envisioned doing this with these types of plots that I'm going to guide you through a little bit. So there's kind of two plots overlaid on one another. There's a bar chart, and then there's this kind of line, this dot and line graph, right? So it's showing the same data two different ways. So it's showing you in the bar chart individual values on the left-hand y-axis, and then on the right-hand y-axis, the line chart is showing you the cumulative percentage total, but it's showing you the same data. So this red bar here is the highest count value at like maybe 65, 67, and that accounts for this like 70% cumulative total of the variance. So the red is one source of variance, the yellow is another source of variance, green is a third source of variance, and so on. So by far, automatically our eye is drawn to this red bar as being the highest source of variance in this particular system. So he envisioned having these sources of variance be reflective of LC-MS systems. So maybe retention time variance is the highest source of variance in a mass spectrometry data set, how much retention time is drifting. Maybe peak area is another. FWHM stands for full width, half max, and then peak symmetry. So some of these words might be reminding you of what we were talking about yesterday when we were going through data and talking about the quality of data and what to look for in a chromatogram and what to look for in a spectra. So all of these are being reflective in these statistical plots showing variance. So now we come to AutoQC. So changing gears again, AutoQC was just noticing, this was Vigisha noticing this problem where it was kind of monotonous, it was kind of tedious to monitor these types of runs on your mass spectrometer. You relied on people in your lab being good lab mates and running their system suitability samples, and it relied on you being a good researcher and running those and analyzing all of that data. So the solution was, let's make this small program that'll kind of run in the background on your instrument's computer. It'll monitor a folder where you'll collect all of your quality control, all your system suitability samples. It'll automatically, without you doing anything besides checking a box and saying run AutoQC, it'll collect all of that data, monitor that folder, analyze it all in Skyline, push it up into Panorama Public, and create all of these plots for you. So all you had to do was check a box and queue those samples on your mass spectrometer, and all of these analyses will be done for you. So that's pretty fantastic. And if AutoQC sounds like something you'd like to implement in your lab, I have this slide in here for reference later, how to set up AutoQC. This is that Panorama web that you were just going to before with Vigisha. You will notice I've boxed in red on the side, quality control with AutoQC. If you go there, there's a full step-by-step guide for how to set this up on your instrument computer. But now I want to put all the lecture stuff behind us and move on to a little bit of introduction to AutoQC and show you how it actually works. So if you'd like, you can play along by going to panoramaweb.org. If you would like to just follow my slides, that's fine too. The 3 points that I hope you take home from this are initializing an automated QC monitoring system, familiarizing yourself with these Levi-Jennings type of plots, and then navigating the Panorama web interface. So you guys are already pros and you're already done with that last one because Vigisha got you all up to speed on navigating Panorama. So if you're playing along, I'm going to the panoramaweb.org website, and on the right-hand side, there's something called example data. So we'd be going down to example data, and then we should see something like quality control example using data from the SProCop tutorial. Whoop, one more time. Oh, these are screenshots. These are, yeah, sorry about that. So this is on the right-hand side under pages, example data. Did you get that? And then under the example data, quality control example using data from the SProCop tutorial. And all of these are in the slides as well so that you can take these home and do them again. And then it should bring you to a page, maybe something like this. Something like this. Is it taking a minute to load, maybe? So what we're seeing here, and I'll just point out a couple features, and then I'm going to kind of walk around and let you just go rogue and click anywhere in here to investigate it yourself. On the top, I don't know if this works. Does this work? Yeah. On the top here, you see QC summary, and it says that there's 47 sample files in here, monitoring 7 precursors. So there were 7 peptides, 7 precursors that we were using for our system suitability in this targeted example of system suitability. You'll notice on the right-hand side of the QC summary, there's the word AutoQC with an open circle. This means it's not currently running. This circle can also be red, which means it's an active profile, but it's not running at this exact time, or it can be green, which means I am currently monitoring a folder on the instrument right as we speak. You'll see in the QC plots pane, there's a couple of options up here. There's metric with a drop-down menu, and you can change between different metrics that you should be monitoring for LCMS system suitability. There's a date range, so you can look at the entire lifespan that you've been monitoring system suitability on your instrument. There's a couple different options for plots. And then in the plot down here, the different peptides that were being monitored for system suitability are shown in each of the different colors. So very quickly, your eye should be drawn to points in time where these lines are no longer stable. So you might be drawn on the left here, your eye may be drawn to this point over here. So if you hover your mouse over that red X, you might see a note that explains why that point might have gone out of spec. So I'm going to take just maybe 5 or 10 minutes to let you click around in here, and I'll come around if you have questions, and then we're going to regroup. So in the interest of making sure we get out for coffee, I'll go on. If you want to keep playing around in the SProCop example data, please feel free. But I wanted to make sure I was able to show you some actual from my own QC folder examples. So this is not something you can navigate to in Panorama because it is my personal Panorama folder that is not public. So this is under the Macass lab. We have a lab-wide Panorama folder, and then we have a specific folder for QC. And then the way we've broken it down in our lab, seems to work for us, is that each one of our instruments in the lab has a directory, and then all the users on that instrument have a personal directory. So this is showing one of our QEs, our Q executives, and then my personal folder under the Q executive. So I took a little bit of a story in screenshots from when I was at the height of my data collection in my PhD. So at this point, the QC was last pinged on January 1st, January 17th of this year. So my QC summary showed that I had 275 system suitability files monitoring 17 precursors. For our system suitability sample, we were using the PRTC peptides, so the synthetic IRT peptides, in a BSA digest. So it was the 15 peptides from the PRTC mix plus 2 peptides from a BSA digest. Just showing you some of the data going from November of 2017 all the way to January of this year. My retention time on the y-axis, my retention times looked pretty steady and then went crazy on November 4th, and then went steady again and then dropped a little bit. So this would be something that if I was watching my AutoQC all the way through November and then I saw this one system suitability just go nuts, I would probably rush in and check my instrument and make sure nothing was wrong. This small shift that happened between late November and then again in January was just I got off the instrument, and then when I got back on the instrument, I was on a new column. So when you see parallel lines in retention time and then a shift downward and then parallel lines again, that's usually indicative that you changed the column. If you want more information about these things, I've got some links in here, but I'm going to show you some examples from this data folder. So again, this is not something you can see because it's in the McCoss specific lab folder. This is showing you a high level of that instrument, that Q-Exactive HF instrument. It's a little blurry on the projector, but maybe you can see on the slides that we have posted up that there are 1, 2, 3, 4, 5, 6, 7, 8 different users on this instrument. Nobody at the time was running AutoQC. So whoever was on, shame on them. They should have been running AutoQC. At the time, oh, no, Jen was running AutoQC, sorry. This is the green circle on AutoQC is showing that it was currently running at the time. So of the other users, 1, 2, 3 had never run AutoQC on this particular instrument. It's an open circle AutoQC. They have a profile, but they never collected QC samples. The other 1, 2, 3, 4 users have profiles and have collected AutoQC data on this instrument, but their profile was not currently running. They weren't the current user on the instrument. And then Jen was the current user on the instrument running AutoQC. So looking at my own data, going from now December, this is my lifetime data at the time, going from December of 2016 through September of 2017, about a year's worth of data almost of quality control data. Your eye is drawn, maybe my eye is drawn to the left at how variable this data was in December. So my performance, my system suitability performance was very low in December because these points are kind of scattered. They're not very parallel. There's not a clear trend. And then you can kind of see by the time January came around, I had stabilized the system suitability when I was on this instrument because these lines became a lot more parallel. So it's probably, since this is retention time, this is indicating to me that my liquid chromatography was not particularly good. This was pretty early into my data collection, so this was probably, I was not very good at packing my own columns at the time. So maybe this is column packing variability, and then I got pretty good at packing columns, and the retention time stabilized. If we look at peak area, this might be an indication of how clean or dirty the instrument is. So you can kind of see how variable some of these peak areas are. Again, in December, the peak area was pretty low in December. The intensity was pretty low. So maybe the instrument was dirty and I needed to clean it in December. And then once I started to learn more about monitoring instrument performance, I got better and my peak areas increased and started looking a little bit more intense. This might be indicative that that front part of my instrument where ions are going in becomes dirty. Some of this is very easy to clean, and then the deeper you get into the instrument, the harder and harder it is to clean. full width half max is a measure of peak area as well. So typically the peak area and the full width half max might be related. Here, I don't see anything too much that's indicating any particular instrument performance issues. It's a little variable, but it's pretty hard to tell because it's small values to begin with. Mass accuracy, there's a couple points in here that your eye is drawn to that just look like party confetti. So these are indicative of pretty terrible runs, the party confetti. More interesting though is if you look really closely, you might be able to see some trends where the points start increasing and then drop, and then start increasing again and then drop. So this is a trend in Orbitraps in a lot of systems where the mass accuracy starts to become uncalibrated over time. And then you can run a calibration on the instrument and that drops the mass accuracy again. You want the mass accuracy to be 0 on this scale. So no deviation from calibrated. And then you can see the lines start to increase where I'm deviating more and more from calibrated until I perform a system calibration that drops back down to 0. So this is sometimes a good metric to see how well different users are taking care of a mass spectrometer, because if users are always leaving the instrument uncalibrated, you can kind of call them out on it. So I'm zooming in here. I changed the date range in Panorama Web, changed the date range and zoomed in on a period from March, mid-March, to the beginning of April. So this is just showing 2 weeks. One solid chunk of data collection where I was on the instrument nonstop. And if we look at peak area, we're looking at peak area on the Y. So we're plotting peak area for all these peptides, and we notice abruptly the peak area drops, drops to almost nothing. But we look at the same date range and we look at retention time, and it doesn't look too bad. There's 1, 2 peptides that kind of drop. But if I toggle between these 2 metrics, so peak area drops abruptly, but retention time doesn't seem to be changing. This was indicative of me, and mass accuracy. You can see when I first got on the instrument, the mass accuracy was a little high. I'm a bit of a stickler, so it was only about 5 ppm, but that was high for me. So I calibrated back down to 0. So there's that drop where I took care of my instrument performance and calibrated, and then you see it climbs up, just naturally climbs up over time. So I had calibrated the instrument. The retention time looked okay, but my peak area dropped dramatically. So this was, I just ran out of sample in my autosampler vial. So I was drawing no sample from my autosampler vial, but this was something that I see in my AutoQC. I can tell something's wrong. It turned out to be not a big deal. I was just running out of sample in my autosampler vial. However, there can be more catastrophic changes. So if something might happen to your LC system, maybe you run out of solvent on an LC system or your pressure backs up on an LC system. These are things that you can catch by running quality control samples with your system suitability. With Panorama Web, you can create these variance plots for your data using what's called a guide set. So we can talk about that more if you are interested, but it's just selecting a certain set of dates that says these set of dates are normal for me. The variance represented in this set of dates is normal for me, so I want to compare all my data to this set of dates right here. So this is showing for one of those guide sets that I said this is normal for me, this is representative of my performance that I always want to have on my instrument. So you see there's one extremely high source of variance and pretty much nothing else contributes to the variance in my data. So I was surprised to learn what that source of variance was. I thought for sure it would be something like retention time drift, but it turned out for me, it was the full width at base. So this was just how wide my peaks were at the base. So that was pretty crazy to me. So it's not typically a metric that you would expect to see have high variance. When I look at the data though, you might notice that these values are pretty small to begin with. So any variance when the values are already pretty small, was contributing a massive source of variance. If I look at my number 2 source of variance, it was peak area. So we're looking at this gray set here that I said this represents normal performance for me on this instrument. My peak area doesn't look too bad. There's this one pink peptide that's a little bit varying. If I look at my retention time, I had incredibly stable retention times. The little hump at the beginning is when I put on a new column that had never been exposed to peptides before. As it becomes exposed to peptides, retention times will shift a little until they settle down. So that's also normal. The first few samples on a column, a fresh new column, are always going to be more varying than a conditioned column. So that's what that's showing there. And if you have any questions, we've got some time. If you don't have questions, let's go into Panorama Web and start clicking around in that data set again. A question? You can set it to monitor a folder that was collected in the past by adjusting one of the parameters in AutoQC to have it watch the folder from files older, right, Pagisha? Yeah. So typically, I think we have our parameters set for files no older than like 3 days or something. Does that sound right? I want to say it's, yeah. But you could, on that first instance that you start up AutoQC, if the files are still sitting on your computer, you can just say like from like 10 years ago, pull in all files that match this particular setting.
Already in there, and that would effectively be a second AutoQC is doing. So a lot of people will kind of use something that they maybe were doing manually as kind of a starting point, and then these AutoQC to increment beyond there, but you could when it makes the manual.
Yeah, it's a good point. Yeah, more questions?
Yeah, so the AutoQC actually rely on the Skyline picking ability, right?
Yeah, it does.
The question is, according to your matter, what's the minimum amount, like what kind of picture should we actually use in AutoQC? On a signature, we should be, those kind of. So
yeah.
We don't like we speed ourselves by picking around picture.
Yep. No, that's a good question. So that kind of comes back to this first slide that I went a little quickly through. How do you pick a system suitability sample? So I would say it depends what kind of samples you typically run on your instrument. Like I had mentioned, we use the standard synthetic peptides spiked in at a set concentration into a BSA digest. So we just do a bulk BSA digest, spike in PRTC peptides, IRT peptides, synthetic peptides into the BSA standard, then make like 50 aliquots of that sample, like single-use aliquots. And then you can just pull one of those aliquots every time you get on the instrument. So we're, in our lab, more interested in quantitative work than discovery work. So monitoring just a handful of peptides that are extremely stable and span kind of the liquid chromatography range works well for us. But if you do some other type of like small molecule work, probably peptides aren't a good example for you. Our PRTC peptides are spiked in at a concentration that we should always see. So I think we're loading 150 femtomoles on the column. So that should be a screaming signal that should never be missed unless terrible things are happening to the system. Is there any ideas that you have for samples you might use? Mm-hmm. Yeah, probably not every single peptide in a complex mix. I guess I would say like a 25 max maybe, but a representative set of 25 that are always detected and are always stable, that are extremely well characterized 25 peptides. I have seen labs use things like keratin, which is one approach, just monitoring for keratin in a sample. It might be a little dangerous because the levels of keratin might change depending on who's prepping the sample that particular time. I think usually I see least HeLa lysate with some sort of synthetic peptide spiked in, I think is the most common I've seen people use. Does anybody use a QC or a system suitability sample already that's okay with sharing what they use?
I don't remember the name, but it's an OpenMS based workflow. Try it. I'm not 100% happy with it, but for discovery, it's pretty much the same from the setup as compared to this program.
Yeah.
So you folder, you dump in your HeLa files in this case, and then it automatically uploads the raw files, and then you can access it via website, and you can also look at tons of different jobs.
So that's monitoring a HeLa sample. So an aliquot of HeLa sample. Yeah. I'd say HeLa is probably the most common I see. Qplot?
Qcloud.
Qcloud. Haha. Clever.
We use some kind of a manual approach. We use this years standard, and then we pull out all these data in the Skyline and then try to see whether there is any shift in the detection time.
Yeah, that's what I did before AutoQC as well. Just dumping everything into a Skyline document and manually going through. So this is an extremely dovetail type method to that. It just takes a little getting used to seeing the plots. And I think now you can see all the chromatograms too. Did anybody figure out how to see the chromatograms in Panorama Web for the AutoQC? You can check the chromatograms too, if you're interested in shape specifics. So if there's no more questions, I think you are free for coffee. We got through that really fast. Thanks to Vigisha already teaching you. Yeah.